All right, this is normally the part of the course you get very angry. Not with me, but you get angry. Everything that you've been doing, we're going to do backwards. So what we've been doing is we used our derivative to find the rate of change of a quantity. So we found derivative that told us the rate of change from an original function. But what if you know how something's changing, but you don't have the original function? That is, we want to work backwards. So for example, we could find the distance traveled if I knew the velocity from its rate of change. I could find cost, my original cost function, if I knew how cost was changing. So the notation gets kind of weird because this big F is my original function, the little f is my derivative. The reason I say that's weird is you're used to seeing the derivative with that f prime of x. Here, if I take the derivative, then this is what gets the prime on it. And this is what's called the original function, my antiderivative. So I'm going to tell you that x squared is an antiderivative of 2x, right? Because if you had 2x, what was the original function I could have taken the derivative of to get it? Well, x squared, because the derivative of x squared is 2x. However, there's other functions that have the derivative of 2x, because remember when we take derivatives of constants, that becomes 0. So because the derivative of a constant is 0, then what we do is we put this plus c, and we say that x squared plus c is a derivative of 2x, and this piece here, the plus c, is the family of antiderivatives then for any constant. So let's see if we can see a pattern for a formula of how to do these. I'm going to just go through and I'm going to tell you these and then we'll check them. So an antiderivative of x would be x squared over 2. How could I check that? I'm saying if I take the derivative of x squared over 2, I should get x back. And I do. Well, how about an antiderivative of x squared? I'm going to tell you is x cubed over 3. Well, if I check it by taking the derivative, I get x squared. So definitely this would be an antiderivative. An antiderivative of x to the third is x to the fourth over 4. Check it, take the derivative of x to the fourth over 4, and I definitely get x cubed back. So the key here is noticing this pattern. What's happening when we took derivatives, we subtracted 1 from the exponent. Well, what's happening when we're working backwards with antiderivatives, if you notice, we're adding 1 to the exponent, and then whatever the new exponent becomes, that becomes our denominator. Okay, so hopefully you can kind of see that here, but this is going to be our formula that we're going to use that says if I want to find the antiderivative of x, I would do it, because it's x to the first power, by adding 1, so that would be my x squared, and whatever the power is becomes my denominator. All right, there's different notation that you will see and for antiderivatives, which is also the process of integration. So an indefinite integral uses this special symbol, looks like a little s here. Okay, so this is the integral sign. This piece in here is the integrand. I have my variable of integration, my x, and then my antiderivative with respect to that particular variable. So when I use this, I'm actually writing out, I'm looking for an antiderivative, but the process of doing that is called integration. So I could go back to that formula that I said, x to the n plus 1 over n plus 1. That formula is used for the power, and so I have my integral sign, x to the n dx equals this, and then plus my c. I can do this for e to the x because I know the derivative of e to the x is just e to the x. I can also write the definition for the log. If I'm looking on the right-hand side, if I take the derivative of ln of x, I get 1 over x. So the antiderivative of 1 over x, working backwards, would be ln of x. So let's look at some examples. X to the 5th dx. Well, when I integrate this, and most of the time that dx bothers students, in this case, most memorize that after you do this first step, the integral sign and the dx cancel. There's nothing really wrong with that, but this is just telling me, this is like when you write dy dx, what's your variable of interest? So using the power rule, I add 1 to the exponent, and that's what becomes my denominator. And now I can see that I started out with a derivative, and I got the original function, my antiderivative. Every one of these, you should go back and check, take the derivative of this, and see if you get x to the 5th. If I have 1 over square root of x dx, I can change that to x to the 1/2. I can bring the 1/2 to the top, and that makes it a negative. And so now I have it in this power rule form. So I add 1 to my exponent, and that becomes the same as my denominator. So x to the 1/2 plus 1, so that's 2 over 2, which gives me x to the 1/2. That becomes the same for my denominator. Notice when I have 1/2 here, I can bring the 2 up to the top. And then finally, I can change 1/2 to a square root. So in other words, if I took the derivative of 2 square root of x, I would get 1 over square root of x. If I want to find the antiderivative of e to the x, well, it's just e to the x. Just as with derivatives, antiderivatives have these same rules. The constant, you can pull the constant out front, which is kind of nice sometimes to see. The negative rule, I could pull the negative out front before finding antiderivative. Just as we said we could add derivatives or subtract derivatives, guess what? I can do the same with antiderivatives. So I can split up each function and find the antiderivative of each and then add them together. So let's go through a couple more examples. So what I'm going to do here is I'm going to split these into 2, finding antiderivatives, and I'm going to pull the constants out front. So I'll pull the 2 out front. Notice if I pull the 3 out front, I have to put a 1 back there, right? Because 3 times 1 is 3, so I'd get that back. And now the antiderivative of e to the x is just e to the x. The antiderivative of 1 over x is ln of x. And so then I just put my constants back out front. If I want to find this antiderivative, I move the x to the -3, I move that to the top. I pull the constant out front. Now I simply have my power where I add 1 to my exponent. -3 plus 1 gives me -2. I can cancel this 2 with the 4, and that gives me 2. I still have the negative, and then I brought the x to the -2 down to the denominator. Had something that looked like this. Probably what I would do is separate these into 2 fractions. And now x to the 3rd over x squared would just be x. And now I'm looking at the antiderivative of 3. I brought the x squared to the top and made this negative. So now I have power. That's x to the first power. I add 1. X to the -2. I add 1. I get x squared over 2. I get, this is still this minus sign. I get 3x to the -1. The bottom becomes -1. So I bring this x down to the bottom. This negative and this negative is how I got a positive. Something like this, I probably would go ahead and just multiply because I want to be able to use the power rule. And now I simply add 1. So you see the 4, add 1 here, you see the 2, and then I can do any canceling that's needed. Now be careful with something like this. You cannot find these derivatives separately, because if you think of working backwards, we had a product rule, right? And so the indefinite integral of a product is not the product of the indefinite integral. In other words, you cannot find the antiderivative of x and then find the antiderivative of this one. You will not get the right answer. So you have to be careful with that. All right, let's see antiderivatives in action. Business application. If the marginal cost, we know when we studied marginal cost that marginal cost means the derivative of the cost function. So I have the derivative, I don't have the original function. Producing X units of a commodity is given by this. The fixed cost is 2,000. Find the cost function and the cost of producing 20 units. So the cost function then is the antiderivative, and I find that by my power rule. So I get my antiderivative plus a constant. Now I just used K instead of C because I didn't want you to get confused with cost. Well, they tell me what fixed costs are when you're producing 20 units. So in other words, oh, I'm sorry, not that yet. The fixed cost is 2,000. Well, fixed cost is when you don't do anything, when your number of units is 0. And so I can see solving for my constant, I'm going to get 2,000. And so I simply plug in 2,000 and that gives me my cost function. Now it says, find the cost of producing 20 units. Well, I have my cost function, so I just simply plug in 20. Let's look at marginal average cost. So that line is the average of producing X digital sports watches is given by this function, where average cost of 100 of these watches is $30. Find the average cost function and the cost function and what are fixed cost. So if I have the marginal average, then to be able to find my cost function, what I did is I pulled out this constant, or I should say my average cost. I pulled out this constant. I brought the X squared to the top, so that made it negative. And so now I can do my power rule and get this value. In this case, I have been told that if my average cost for 100 watches was $30, I can plug this into my function that I just found and I can solve it for K, for my constant, which goes into the function that I just found, and that gives me my average cost function. So I found the average cost function. I want to find the actual cost function. If you remember, how do you find average? You take the total here, cost, over per unit, right? So what if I just took this and I solved it for cost, because that's what I want to look for? Well, I could do that just by multiplying X by average cost. And so I plug in my average cost that I just found, and of course I could multiply this out and do some canceling to make it look a little nicer. Then it says, what are fixed costs? Well, fixed cost is when you don't sell anything, when X equals 0. So plug in X equals 0 into your cost function, and you will see you get the 1,900.